Hi, I'm Jacob Carney of the Department of Environmental Science and Energy Research at the Weizmann Institute. We've been working here for the last 20 years on various methods to convert solar energy to either fuel or electrical power. For the first 10 years, we concentrated on electrical power and have been able to get to the point where two of our innovations are now being commercialized by companies, startup companies in Israel. Over the last 10 years, we have looked into the possibility of converting solar energy to fuels. The reasoning for it is that solar energy cannot be used at night directly, or it cannot be used where there isn't enough sun. So a mean to store and transport solar energy is vital to make it the largest energy resource that we are using, not as a side solution to fossil fuel or nuclear. Over the last 10 years, we have tried to find ways to convert water to hydrogen and oxygen, and later carbon dioxide to carbon monoxide and oxygen. Our approach, maybe the unique thing that we are doing relative to what's done elsewhere, is that what we emphasize is an overall, from sun to the product, high efficiency. The logic for it is that when you use solar energy, we all know that it's very costly, and the reason it's costly is the collection area. The collection area is what costs a lot of money in solar energy. If you increase the efficiency, you can reduce this cost. So we have become fanatic about increasing the efficiency of our solar system. The project that we have working on, and recently with the aid of iSafe, is enable us to convert solar energy to fuel at an efficiency of about 50%, which is roughly an order of magnitude higher than what's been done using other approaches, where the efficiency in most cases is on the order of 5%, hoping to reach 10% eventually. Our results, our measurements, backed by modeling, indicates that we can indeed reach this kind of efficiency of 50%. The project that we are doing with iSafe is high efficiency, clean fuel production from carbon dioxide and water using solar energy at high temperatures. The main problem here, of course, is that we have two problems. First, we are emitting carbon dioxide to the atmosphere at a rate that makes us all very uncomfortable. And secondly, we are running out, we're exhausting our energy resources to the point where we are looking to the future and we don't know where we're going to get some, and we know if we're going to get it, it's going to be highly polluted, very expensive. And in the last 20 years, we already see the outcome of this in terms of global frictions, especially around us in the Middle East. The solution that we are offering is to take carbon dioxide from the fuel stacks of power plants or cement factories and use solar energy, concentrated solar energy, to convert it to fuel, simply by dissociating the carbon dioxide to carbon monoxide and oxygen. We can do it just with carbon dioxide, or we can add water to it, and then we will have a mix of carbon monoxide and hydrogen. This mix is called syngas, and with syngas you basically can produce any fuel you wish. You want to have an aviation fuel, diesel, gasoline, you could do that. But probably more useful would be to convert it, and easier would be to convert it to methanol or ethanol that can be used as alternative fuels to gasoline in cars. If we are successful here, and this can be done economically, we will have a global alternative to fossil fuels that is clean and available everywhere. We would be able to use it for decades and diffuse friction around the globe and make sure that everybody gets power and fuels whenever they need it. The work with iSafe has enabled us to really significantly accelerate the rate at which we are solving these problems and reaching results that are indicating that we can do it commercially. First of all, we've been able to form a strong cooperation with Dr. Avner Rothschild and his group at the Technion, where they are concentrating and providing excellent solutions to fundamental material problems we have in the systems. This is expertise that we don't have, while we are continuing here with the testing of the component, the modeling, and the integrating this into a system that works with concentrated solar energy. This could not have been done without iSafe, and if it could, it would have taken us a lot longer. We already see the impact of this, because recently, actually 2 weeks ago, the Weizmann Institute commercialization arm, the company that's in charge of technology transfer to industry, YEDA, closed and signed a license agreement with investors to commercialize this technology that iSafe helped us develop and reach this level. If all goes well, in something around 3 years, we will start seeing the first plants using this technology. And I'm very, very optimistic that we're going to be able to do it. I want to say a few words about what iSafe is doing and why, for me and my colleagues here in Technion, it's been just providing us just with a great opportunity. I don't know if we would have had otherwise. No other funding agency in Israel provide money for that stage where you already have a concept and you want to take it to the point where industry will become interested. The funding that comes from the Israeli government is just not sufficient to do that. And iSafe, already our project is a proof that iSafe can do that with our technology and hopefully with others in renewable energy. And I just think it's a wonderful idea. That the only problem here is that it should have had a lot more funding so they could support other projects, give more money to each project, extend the work for more than a couple of years. And I'm looking forward for them doing it. And I, for one, will do everything I can to help iSafe and other people, other scientists benefit from what they do. Thank you very much.